It's good to see a couple here, Daniel and Kevin. Couldn't have asked for better.
How's it going there? You want us to keep the video off again?
Please keep the video off. It works better. It don't use up as many megabytes and all this kind of good stuff.
Great.
Appreciate it, Daniel. What'd you do? Use up your lunch hour to come here?
Yes, sir.
That's all right. Whatever works, works. Kevin, are you with me? Okay, today we're going to look at two good topics. I really started to reverse them. 2.3 is a better topic than 2.2, but I guess we'll crawl before we walk. The whole idea of graphing. Keep this in mind. Graphing, Kevin, you're going to plug in X's and get out Y's. Let me say that again. You're going to plug in X's and get out Y's. Now, there are rare occasions, Daniel, when we'll plug in some Y's and get out X's, but we'll let those ride until we get to the time. Let's make it really simple on ourselves. If I give us something just this simple right here, y is equal to x plus 3. Is my lighting all right on that? Can y'all read that?
Yes, sir.
All right, great. So notice what it says. You plug in x's and you get out y. You can put in any x that you want. So let's give it a try. If I let x be 0, then I've got 0 plus 3. So what's my y value going to be?
3.
3. If I let x be negative 2, what's my y value going to be?
1.
1. Let me say it again. It's that simple, folks, and you can make up your own x's. Hello, Alicia. Glad to see you. The graphing, I know that many of you are going to rely on your calculator to do that, but I'm going to be real frank with you, Kevin. You really need to rely on your brain instead of the calculator for the majority of these graphs. One of the first things that we talk about when we talk about graphing are the intercepts. Now stop and think about it. Let's look at the graph we got there. If I put that down on the x and y axis, well, we just found out that when x is 0, y is 3. So x is 0, y is 3. Agreed? Now, let's try another one. Just good old trial and error. Let's let x be minus 3. Alicia, how much is y going to be when x is minus 3? Kevin, can you answer that?
When how much is x going to be when y is what?
No, when x is 0, how much is y going to be? When x is minus 3, minus 3 plus 3 gives me what?
0.
0. So when x is minus 3, y is 0. Now, from your geometry, it takes 2 points to determine a line. Well, we've just drawn our first graph. When x is 0, y is 3, and when y is 0, x is minus 3. So that's one of the first concepts that we're going to talk about. How do you find the intercepts? And the big idea is simply this. You let x be 0, that's going to find your y-intercept. You let y be 0, and that's going to find your x-intercept. Fair enough?
Yes.
Got it.
Right, and it's that simple. Let's try one like this. So we're going to soup it up just a little bit, and we're going to beat you to death with that particular kind of graph later on. I think particularly when we get to chapter 5, we're a long way from there. The first one is very easy. Let's let x be 0. Well, when x is 0, how much is y going to be?
-9.
-9. Alicia, you agree with that?
Yeah.
All right. Now, but the next one is a little bit harder, Kevin. Let's watch it. On the next one, we're going to let y be 0. Well, make your equation. We just got to saying let y be 0. And then I get x squared minus 9. And that's the reason, Daniel, that second lesson I hammered on it so much. The quadratic equation and how to solve it is going to hone us for the rest of this class. So we might as well get used to taking the shortcuts when they're provided to solve it. There are two ways to solve this problem. In fact, we found that there were 4 ways to solve a quadratic. I can factor, I can use the square root method, I can complete the square, or I can use the formula. I'll repeat what I said earlier. Kevin, never use the formula when you only got 2 terms here, because there has to be a shortcut to doing that. Well, I'm going to take the real shortcut this time. And this time, I'm going to move that 9 to the other side. It becomes a positive 9. Now, Daniel, what am I fixing to do next?
Square root it.
Right, I'm going to take the square root of both sides. So just keep one thing in mind. When you take the square root of both sides, you have to use both the plus and the minus. Fair enough? So look what that says then. That says that when we let y be 0, x was plus 3. And when I let y be 0, x is minus 3. Now, I'm going to get a little bit ahead of ourselves, but there's no reason why we don't get a little bit ahead of ourselves, because we've got 3 good points. We found 0 minus 9. 0 minus 9 is going to be way down here. 3, 0 is over here. And then minus 3, 0 is back here. So if I connect these dots, I get the U-shaped curve. Maybe some of y'all happen to remember the name of that U-shaped curve. It has a particular name. Anybody?
Hyperbola?
Parabola. The hyperbola is harder. The hyperbola has the square terms in it. We'll save that for another course. Fair enough, Daniel?
All right.
Okay. Now, next thing they've got that we need to look at is something like this. If I give you an equation, now that's my equation. Y is equal to x to the 4th minus the square root of x. Well, we're not going to try to find the intercepts and so forth on this one, because that's very, very difficult to do. Here's what the question is. Is 0, 0 a point? In other words, he wants to know, does 0, 0 work that equation? Alicia, what do you think?
I don't know.
I'll give it a try. Let's plug in x is 0. Z to the 4th power is 0. How much is the square root of 0?
0.
0. And 0 minus 0 is what? 0. So the answer is definitely yes. It is a point. Fair enough?
Mm-hmm.
Okay. Let's see what the next one was. The next one was, is the point 1, 0 there? Well, do it again. Plug it in. How much is 1 to the 4th power?
1.
How much is the square root of 1?
1.
How much is 1 minus 1?
0.
0. So it works too. Kevin, do you get the idea of plugging in?
Yes, I do.
Yeah, whatever x they give you, plug it in and do the arithmetic. That's a crucial thing. I know it sounds very elementary, but it's a crucial thing that we're able to do that. Because, let's see, he gave me this one right here. X squared plus y squared is equal to 4. That's the equation. And I promise you, Daniel, we're going to beat you to death with that before it's over with. That thing is a circle, and we'll worry about why it's a circle later on. But that's not what I'm interested in for this particular problem. This particular problem is 0, 2 a point. Y'all do it. Plug in 0 for x and see what you get for y.
You want us to answer now?
Yeah, I want you to answer.
I think it is. It's 2, right?
Right, because 0 squared is 0, 2 squared is 4, 0 plus 4 is 4, right?
Right.
All right, try this next one. Is the square root of 2 and the square root of 2 a point on that graph? And as soon as one of y'all got it, let me know.
It is.
It is. because the square root of 2 squared is 2. 2 plus 2 is what? 4. So Alicia, we got the idea that we can plug in whatever we want. Agreed?
Yeah.
Now, in this particular case, he's telling you what to plug in. Now, later on, you're going to be asked to find the plug-ins. Now, and here's a perfect example of that. We're going to use the same equation that I got right here. No use copy and jump down. And I'm going to ask you to find the intercepts. Okay, let's go back to what we said earlier. To find the y-intercept, you let x be 0. So I'm going to let x be 0. So I got 0 squared plus y squared is equal to 4. So I got y squared is equal to 4. How much is y if y squared is equal to 4?
2.
2.
2, and it's also what?
-2.
-2. Thank you, Alicia. Don't forget, folks, when you take the square root of both sides, you got to use the plus and the minus. Does that make a little bit of sense?
Yes.
Now, watch the next thing. We're going to turn right back around, and we're going to let the y be 0, and we're going to solve for x. So I got x squared plus 0 squared is 4. Well, we can cut through the board. That's the same type of equation that I just got. X is going to be 2 and -2. Y'all agree with that?
Yeah.
Right, so x is going to be 2, and x is going to be -2. Now, watch this mess. You put that on the XY axis, and then you're not responsible for that in this section. But as I said, it's coming up, and we might as well be ready for it. So this is the point 2, 0. Now stretch your imagination that that's a circle. This is 0 minus 2, and this is -2, 0, and this is 0, -2. So, Daniel, does it make sense that it's going to be a circle?
I believe so. It has to be to touch all the points.
Yeah, touch all those points 2 away from the origin, right?
Or I guess it could be a square too.
Well, it could be a square, but you see, and I want you to listen to yourself. You see, these are not just 4 points here. There are many, many more points up here. For instance, we just found one a while ago. That square root of 2
Oh,
and square root of 2. You got me? Yeah. And when we get there, that's the reason that it's going to make sense for it to be a circle. But for right now, we're trying to emphasize the fact that you find the intercept very easy. You let the x be 0, solve your equation, find your y-intercept. Let the y be 0, solve your equation, then you get the x-intercept. That's not too mind-boggling, I hope, right?
Great.
Okay, now let's move on up a little bit with some good old algebra. In fact, my song and dance, and you're going to hear me say that over and over and over again. Algebra 2 is the most important math class you take. By the way, Kev, I took Algebra 2 in 1957.
Okay, you got me beat a little. I think it was 1982.
All right, now, same song and dance, folks, and we're not going to back off. You don't know what this looks like. I don't care that you don't know what it looks like, but you can still find the intercept. So the first thing we're going to do, we're going to let x be 0. So I got 9 times 0 squared plus 4y squared is 36. So I got 4y squared is 36. I got y squared is 9. Well, we've worked that 2 or 3 times. How do you solve y squared is equal to 9?
3 and -3.
That's right. You're with me. Thank you very much, Alicia. I get 3 and -3. Y'all buy that?
Yes.
Now, I'm going to give y'all a minute or two. I want y'all to find the x-intercept. Let the y be 0 and see what you get before I do it, okay? And as soon as somebody's got a number, tell me what it is.
-2 and 2.
There you go, because you got 9x squared is 36. You got x squared is equal to 4. So you're getting 2, 0, and negative 2, 0. Fair enough? Now, just for the heck of it, since we've already done all the hard work, I want you to watch what happens there. If I put that on the number line, my X-intercepts are 2 and negative 2, and my Y-intercepts are 3 and negative 3. So this time, Daniel, I got an ellipse and not a circle. It can't be a circle because the radius is not the same all the way around. Does that make a little bit of sense?
Yes.
Okay, but as I said, I'm not worried about the graphs now. The graphs are not my interest. So one more time, Alicia, how am I going to find the X-intercept?
Mm,
I'm going to let Y be what? Kevin, how do I find the X-intercept?
Let Y be 0.
Amen, please. And Alicia, that's the whole thing. And if I want to find the Y-intercept, I let X be what?
letting the X be 0.
0. Okay, that's the concept of finding the intercept. Fair enough? Now,
Yes.
another concept is the idea of symmetry. Okay. If I give you a point, and let's say that I give you the point, let's call it 4, 3. Where would do you think I would plot the point over here in the second quadrant so that the y-axis would be the symmetry?
Negative 4, 3.
You're with me. That's great. Okay. So what we're saying is that the y-axis is going to split it in half, right?
Yes.
Now, where would I plot the point down here so that the x-axis would be the symmetry?
4, negative 3.
4 and negative 3. Now, where would I plot the point back here so that using this point right here, what would the symmetry point be here?
Negative 4 and negative 3.
There you go, Alicia. Hang with me. Negative 4 and negative 3. Fair enough? Now, there's something else that we have x-axis symmetry, y-axis symmetry, but I can also have origin symmetry. Origin symmetry simply means this. If I drew a line from this point to this point, what is the midpoint of that line?
0, 0.
Amen. It is the origin. If I draw a point from this line, a line from this point to this point, what is the midpoint of that line?
Same thing.
Same thing. It's still 0, 0. So these 4 points that we have up here have origin symmetry. Does that make any sense?
Yeah, because they all intersect.
Well, at the origin,
Correct. Okay.
right? Okay.
Yes.
Okay, so that's the idea of symmetry. Now, I have to chuckle a little bit, Daniel, because you hollered something about a hyperbola a while ago, and that happens to be one of my examples. So I want you to notice that I'm not going to give you the equation for this particular graph. But look at that graph right there. Doesn't it look like it have y-axis symmetry? If I took this right here and just folded it over, wouldn't it be right on top of this one right here?
Yes, sir.
Yeah, but look at it. Doesn't it also have x-axis symmetry? If I just took the top and flopped it down, wouldn't it lie right on this right here?
That's right.
Yeah, so it has x-axis symmetry and it has y-axis symmetry. Now, as crazy as it might seem, ladies and gentlemen, this thing also has origin symmetry. Stop and think about it now. I'm crude with my graphs, but Alicia, we're still gonna get the point. If I take this point right here, and I take this point right here, and I draw me a line from those 2 points, isn't the origin halfway between them?
But what do you mean?
Yeah, look at it. I'm just taking a point right up here in the first quadrant, and I'm taking it part of the point right down here in the third quadrant. When I draw this line from those 2 points, doesn't the origin, wouldn't that be the center of that line, midpoint of that line?
Yeah.
Yeah, so it has x-axis symmetry, y-axis symmetry, and it has origin symmetry. Now, that's the reason that I love to use that, Daniel, because of this, what the equation for this thing is. The equation for a hyperbola goes something like this. Oh, let me go ahead and use, I'll go ahead and use 25. X squared minus y squared is equal to 25. Could be an equation for that. So if that is the case, then if I let y be 0, then x is going to be 5. And if I let y be 0, x is going to be minus 5. So my 2 intercepts are at 5 and minus 5, right? Now, here's the kicker, and this is what I want y'all to write in your notes. To test for x-axis symmetry, replace the y with a minus y. Let me say it again. To test for x-axis symmetry, replace the y with a minus y. Well, let's give that a try. We're just going to do it for a particular number. Let's let x be 6. No, I want my y. I want y. Let me back off just a little bit. Let's let my y be 1. Well, if my y is 1, I've got x squared minus 1 squared is 25. X squared would be 26. X is plus or minus the square root of 26. Now that's the key to it. I want you to look what happened, Alicia. When I let x be 1, my y is the square root of 26. But when x is 1, my y is also... Shove it up a little bit.
There we go. Thank you.
Yeah, there you go. Now you can see it, right? So I want you to look what happened. When I let x be 1, y was the square root of 26. And when I let x be 1, y was minus the square root of 26. Well, that just says what we said. That says, Daniel, that I got something wrong. Oh, I see where I'm wrong. Man, I made a big boo-boo in his own video, and we can't correct it. Now, here's what happens. I can't let x be 1. There are no x values between minus 5 and 5 that works this thing. I was supposed to let the y be 1. Let's back up and punt, folks. So I'm going to let the y be 1. Now, when I let the y be 1, then I got my x is the square root of 26. So the point was supposed to have been right here. When I let y be 1, my x was the square root of 26. And when I let y be 1, my x is minus the square root of 26. Minus the square root of 26 would have been this point back over here. But the big deal is this. I want you to look at it. When I let y be 1, x is the square root of 26. And when I let y be 1, x is minus the square root of 26.
Can you move the notebook up to the graph?
Okay, good. Thank you. Now, look what happens here. When I let y be 1, my x is the square root of 26. And when I let y be 1, x is minus the square root of 26. So we can keep the arithmetic that we had down here. But the big deal is this. Look at this point right here and look at this point right here. Isn't the y-axis the symmetry there between those 2 points?
Yes.
Yeah, it splits it half in two. I got square root of 26 over here. I got minus the square root of 26 over here. Fair enough?
Correct.
Okay. So here's what the big deal is. This, I want y'all to write it down. I'm not going to take the time to write it down.
Okay.
Wait, we lost you.
Replace the y with a minus y. And the x-axis, x number stays the same. It is x-axis symmetry. I'm gonna repeat it 2 or 3 times. When you replace the y with a minus y, and the x value stays the same, then you have x-axis symmetry. When you replace the x with a minus x, then you have y-axis symmetry. All right, let me back up and look at that circle that we had a while ago. Look at that circle. In that circle, I had 0, 2 for one of the points, and then down here I had 0, minus 2. So the x value stayed the same, but the y values went from 2 to minus 2. That means the x-axis is cutting it in two, half in two. Does that make a little bit of sense? Look at it, 0, 2 up here, 0, minus 2 down here, right?
Yeah.
So the x-axis is what's cutting it half in two. Fair enough?
Yeah.
Now, watch the other mess. Look at this minus 2, 0, and this 2, 0. Well, my y value stayed the same, but the exact value went from a negative 2 to a positive 2, right?
Correct.
So that means that, look at it, isn't the x-axis cutting it half in two?
Mm-hmm.
Yeah. So you can have x-axis symmetry, you can have y-axis symmetry, and then I showed you a while ago that you could also have origin symmetry.
Mm-hmm.
Okay. One more little bit of symmetry of a type that we're going to see many, many times. Y is equal to x squared plus 4. Now, as I said, I can't hold you responsible for drawing the graph right now, but we need to review, Alicia, the whole concept of plugging in numbers. So if I let x be 0 in this problem, how much is y going to be?
4.
4. No big deal, right, Kev?
Correct.
0 plus. Now, if I let x be 1, 1 squared is 1 plus 4 gives me 5. Is that right?
Mm-hmm.
Now, if I let x be minus 1, I still get 5. Now, when I connect the dots of this thing, Daniel, what does it look like the symmetry is?
Y-axis.
The y-axis, and the reason is very simple. When you replace the x with a minus x, the y value stayed the same. Get that point? Look at it. When I use 1 and minus 1 for x, the y value still stayed 5. Fair enough?
That's cool, yeah.
Yeah. So what it says then, I mean, we can stretch ourselves out and I say, hey, I'm going to use any old x. I'm going to let it be minus. But what happens when you square a minus?
Positive.
You get positive. So here's the big deal. And folks, it is a really big deal. Look at the equation you had to start with. It was y is equal to x squared plus 4. Look at the equation that we ended up with. Same thing, right? And that is your test for symmetry. When you can replace the x with a minus x and you get the same equation, then it is y-axis symmetry. And it works that way every time. Now, Daniel, let's cheat just a little bit. Kevin, we all like to cheat. All right, let me give you a shortcut, folks. Alicia, every time it is x squared, and that's the only x that you got, then it's going to be Y symmetry. Now, don't let me put words in your mouth. I didn't just say X. I said X squared, because let me give you an equation like this. You got X squared. I'm not going to box myself into a corner, not too much anyway, minus 2X minus 3. Now, so Daniel, I don't have just an X squared, is that right?
You have a binomial?
Worse than that, it's a trinomial, right?
Oh, yeah.
Got three terms. I got X squared minus 2X minus 3, right? Well, I'm trying to make my point, and my point is very, very important, Alicia. That's the reason that I'm taking the time, and I know you think I'm wasting your time, but let's jump ahead just a little bit. The only factors of 3 are 3 and 1. I'm having a minus 3 and a plus 1. Do y'all agree that that would be the factors of this X squared minus 2X minus 3?
Yeah.
Yeah.
Okay, so what that says then is that I got a 3, 1 over here, and I mean a 3, 0 over here, and I got a minus 1, 0 over here. But the big deal is this right here. When you draw this graph, that's what it's going to look like. Now, you're not responsible for the graph right now, but you are responsible for being able to answer my question about symmetry. Look at it, Daniel. The y-axis is not splitting it half in two, is that right?
Correct.
It doesn't have y-axis symmetry. And the reason it doesn't have is I can't just replace the x with a minus x and keep the equation. Now, I know this seems rinky-dink, but let's try it. Everywhere I got an x, I'm going to put a minus x. Now, all I did, I took the original equation that I had right here, and everywhere I had an x, I put a minus x. Well, we've already said negative x squared comes out to be x squared. Is that right?
Right.
Now, negative 2 times x is positive 2x, and then a negative 3. Now, I want you to look at this equation. The x squared plus 2x minus 3. It's not the same thing as x squared minus 2x minus 3. Is that clear?
Yeah.
Yeah, so it doesn't have y-axis symmetry, because when I replace the x with a minus x, the thing changed on me. Fair enough? Now, it does have some symmetry, and we're going to learn later on, Kevin, that the symmetry is very, very simple. The line of symmetry just thing runs right down through that little point down there, and we're going to have names for that, but we'll worry about those names later on. Okay, that was section 2.2. Let's get to section 2.3. And 2.3 is one that you better put your star by, because I promise you, we're going to beat you to death with this thing before it's all over with. And this section, Daniel, is all about linear graphs. In other words, we're going to get straight lines when we draw the graphs. Well, we already did one, and let's go ahead and let's do us another one. If I got y is equal to x minus 4. Now, let's review what we've already learned. In this particular case, if I let x be 0, how much is y going to be?
0.
No. Let x be 0. How much is
Minus
y
4.
going to be?
Minus.
Negative 4. When x is 0, y is negative 4. Is that all right?
Yes.
Now, I want you to turn right back around, and I want you to let y be 0. And I want y'all to do the arithmetic before I do. Let y be 0 and tell me what x is.
Negative 4.
Very, very close. It comes out to be
Oh, 4, yeah.
positive 4, right? Now, let's do the arithmetic together. We're going to let y be 0. 0 is equal to x minus 4. What do I do with this minus 4?
Yeah, it's positive. Yeah.
Right, you add it to this side, and so how much is my x value? Going to be 4. Does that make a little bit of sense?
Yeah.
Okay, so a linear graph, 99% of the time, the best thing to do is to find the two intercepts. Well, we just got through finding that when x is 0, y is -4. And then when x is 4, y is 0. Therefore, this is my graph. And Kevin, it's that simple. Let's don't make it complicated. Fair enough? So
Simple's great.
right. The majority of the time, folks, every time you want to draw a straight line, you should find your x and y intercept. There's only one exception to that, and I'll try to show you the exception a little bit later on. Now, with linear graphs, we got some equations. In fact, they're formulas. And you, whoa, I got some background noise. Hey, Kevin, turn off your. Okay. One of the first formulas that we got that's associated with this is this. M is equal to y2 minus y1 over x2 minus x1. That is called the slope formula. That's the way you find the slope of the line. Y minus y divided by x minus x.
You said that's the slope formula?
That's the slope formula. Keep it in mind. Now, this next one is crucial. Y minus y1 is m times x minus x1. That has a name. That is called the point slope form of a line. Point
Say it one more time, please.
slope form of a line. To use the equation, you need to know one point and you need to know its slope. Let me repeat, you need to know one point and you need to know its slope. Fair enough?
Well,
Now,
the audio cut out when you said the name. I don't know if it was just for me.
okay, it is called the point slope form.
Got it.
You need to know one point and the slope. And the third equation that's associated with this is y is equal to mx plus b. Mx plus b has a very unique name, and we use it, Alicia, all the time. That's called the slope Y-intercept form. Slope Y-intercept form. Now, let's get familiar with all three of these points. And I'm going to take the last one first because it's the easiest one for us to deal with. Y is equal to 3x plus 6. Now, that's my equation. Now, I want you to look at that formula that I wrote right there. The M, Daniel, stands for the slope, and the B is the Y-intercept. Oh, look, okay? Now, in my problem right here, how much is my slope?
3.
3. Agreed? Now, so what happened when x is 0 in this problem, my Y-intercept is 6. Is that right?
Correct.
Now, so if I look at it from a graph standpoint, we know that 0, 6 is a point over here on it. Agreed? Now, let's review a little bit. I want y'all to let y be 0, and I want you to figure out the x for me. In other words, I want y'all to find the x-intercept. Let y be 0. Solve that equation.
-2.
And you're going to get a -2 because you got -6 is 3x. So -2 is equal to x. Therefore, I got -2 and 0. Now, when I get those 2 points, Kevin, I can draw my line. Fair enough?
Yeah.
Now, Alicia, maybe y'all remember way back there. Have y'all ever heard rise over run? Ever heard that?
That word?
Rise over run. Rise over run is what the slope is. the slope of a line is the rise divided by the run. Fair enough? Now, I want y'all to watch this mess right here. Here's my line. Look at this little triangle right here. If I get on this point right here, I have to move over 2 to get there. And I'm at here and I move up and I move over 6. So in this problem that I got right here, my rise was 6 and my run is 2. But what do you get when you divide 6 by 2?
3.
And what's my slope?
Yeah, 3.
Yeah, it's 3. Hey, Daniel, it works every time.
That's
If,
cool.
if I can get me 2 points on a line, then I can find the slope by using that little right triangle. But there's an easier way to do it. In fact, we've got the easier way because we've got the formula. Look at our formula again. Our formula says y2 minus y1 over x2 minus x1, right? It says subtract the y's, put it on top, subtract the x's, and put it on the bottom. Well, look at my equation right here. Y was 6 and y was 0. How much is 6 minus 0?
6.
Right. Now, x was 0 and x is minus 2. So 6 minus 0 is 6. 0 minus a minus 2 comes out to be 2. And again, how much is that 6 divided by 2?
3.
3. Hey, Kevin, it works every time. If you give me 2 points, then you can plug in those 2 points and you can find that slope every time, every time. Fair enough?
Yeah.
Believe it or not, folks, it's that simple. If you got 2 points, you can always find your slope. But now, if you're lucky enough to have been given the equation to start with, you don't have to do all that mess. The slope is automatically what?
3.
3. And this number over here is automatically your Y-intercept, right?
Correct.
Yeah, so don't do any more than you have to. Fair enough?
Very.
All right. Daniel, do you remember what we called that? What name we gave that?
Point slope.
Point slope. Okay. So here's the problem. Okay, that's the problem. Find the equation of a line with a slope of 4 and a point 2, 3. Kevin, all you do is plug in, totally plug in. So you get y minus 3 is the slope, which is 4 times x minus 2. That's your first step. So let's don't make it complicated. Simply plug it in. Now let's do a little bit of arithmetic. I got y minus 3 is 4x minus 8. So y is going to be 4x minus 5. Don't let me make a mistake with the arithmetic, Daniel. I bring this 3 over, it becomes positive, right? So that's a 5. So this is the answer to my problem. That is the equation of that line that has a slope of 4 and it goes through the point 2, 3. Fair enough?
Yeah.
Now let's do another one. Now I want the equation of the line, and all I give you is 2 points. If I give you 2 points, what can you always find? The slope, folks. When I give you 2 points, you can find the slope. Fair enough?
Mm-hmm.
Okay, so it's going to be 6 minus 4 divided by 5 minus 3, which comes out to be 2 over 2, which is 1. So, Kevin, I'm trying to be kind to y'all to make the arithmetic come out nice and convenient. Fair enough?
Mm-hmm.
Okay, now, I want you to watch this next little ditty and be careful with what we're doing with it. Daniel, excuse me. We keep going back to the formula, and it said I needed to know 1 point and the slope. Well, I know 2 points, so but I can only use one of them. So I'm going to use my formula, and I got y minus 4 is equal to 1 times x minus 3. I used the 0.34. Okay, so I got y minus 4 is equal to x minus 3. So y comes out to be x plus 1. So that's my equation. Now, I want y'all to watch what happened, and it's important that you recognize that fact. If I were to use the other point, I'd have y minus 6 is 1 times x minus 5. And I still get y is equal to x plus 1. So, Alicia, I don't care which one of these points you use, the answer to this problem is going to be y is equal to x plus 1. Does that make a little bit of sense?
Yeah.
Now, I'm going to say it one more time, Kevin, because it's important. When you use this formula, you can't use but 1 point. You find your slope and you pick one of those points that you just had. Fair enough?
Mm-hmm.
Okay. Now, we run into a little bit of problem with the special cases, and the special cases run us up the wall. And the first special case we're going to have is dealing with the horizontal line. Daniel, horizontal line means it's flat, is that right?
Means the what?
Horizontal line is going to be flat, correct?
Oh, correct.
Yeah, so it has no rise. Y'all agree with that?
Correct.
So the slope of a horizontal line is always going to be 0. If you don't know that, put it in your notes. Okay, Kevin? The slope of a horizontal line is always going to be 0. It's flat. It has a 0 rise. Fair enough? Now, you say, well, how can that be? Well, it can be very, very simple. If I tell you that y is equal to 5, Alicia, that says I don't care what the x is, y is always going to be what?
5.
5. So what that says then, if I let x be 1, y is 5. If I let x be 2, y is 5. If I let x be minus 6, y is still what?
5.
5. Now, you say, well, how can that be? Well, Daniel, the reason that it can be is that we disguise the graph a little bit. The number right here happened to be 0 in front of x, because how much is 0 times x?
0.
0. So, but what does that say the slope is?
Oh, 0.
And that's what I just got through saying. Every time it's a horizontal line, it's flat. It has a 0 slope. Is that right?
Yeah, that's cool. So,
Yeah. So when you put it in a graph form, it looks like this then. I've got the 0.15 and I got the 0.25 and all that. But the big deal is this, it is simply a flat line. It has a 0 slope. Does that make a little bit of sense?
yes, sir.
Okay. Now, Alicia, the one that doesn't make sense is the next one. And the next one is the only one you can't use the formulas on. And that's a vertical line. Now, if I give you this point right here, 6, 5, and I give you the 0.61. Now, let's plot that thing. 6, 5 would be up here, and 6, 1 would be here. But when I connect those dots, don't I get a vertical line?
Yes.
Yeah.
Yeah. And now here's the big deal, and it is a big deal, folks. I want y'all to look at this. Let's try the slope formula on this thing, because it's very, very important, Kevin. The slope formula says it's y minus y. So that, yeah, it's going to be y minus y, which is 5 minus 1, over x minus x, which is 6 minus 6, which is going to be 4 divided by 0. Now, that's a big deal. Daniel, how much is 4 divided by 0?
Undefined.
Undefined. You can't have it, right? So, Alicia, what I want all of y'all to put in y'all's notes is this. When it's a vertical line, it has no slope. It is undefined. Fair enough?
Mm-hmm.
Kevin, that make a little bit of sense? Yeah, vertical line, you're going to end up with that 0 in the bottom, and you can't divide by 0. So that's the only exception to being able to use these formulas. You can use the formula to find out that you can't have a slope because it does come out to be 4 divided by 0. Okay, now let's look at a couple of special cases. Now, Daniel, we're going to cheat just a little bit. We're going to use what we've already learned. And then I'm looking at this top equation right here. When x is 0, y is equal to 8. And when y is 0, x is minus 8. So that's the graph that I get. Now, in the second one, when x is 0, y is 4. And when y is 0, x is minus 4. And that's the graph that I'm going to get. Now, that's crude. But, Kevin, what does it look like is true about those two lines? Anything in particular? Alicia, you see anything particular about them? Daniel?
They're perpendicular?
Not perpendicular, they're what?
Oh, parallel, yeah, sorry.
They're parallel. These things are parallel lines. Now, they're parallel lines because I want you to look at it. What is the slope of this line?
1,
What is the slope of this line?
1.
Okay, so Kevin, we need to keep that in mind. When two lines have the same slope, they're parallel. Fair enough?
Correct. Yes.
Yeah, please, that's very, very important. When two lines have the same slope, they are parallel. Then we can make us what we call a hard problem out of it. Okay, that's my equation. Find the equation of a line through 4, 5, and it's going to be parallel to y is equal to 2x plus 6. Well, look at this mess right here. What does that say the slope is going to be?
2.
2. Okay, so I go back to my formula. And my formula says I need to know the slope, and I need to know 1 point. Fair enough? Well, we just found the slope. Slope has to be 2, is that right? Because they're parallel, fair enough?
Right.
Now, I gave you the 1 point, so I got y minus 5 and I got x minus 4. So I got y is going to be 2x minus 8 plus 5. So y is going to be 2x minus 3. Now, I want you to look at this equation right here. The y-intercept on this equation would be how much?
-3.
-3. In our original problem, the y-intercept on that one was how much?
6.
6. So they're still going to be parallel. It just means that they cross the y-axis One of them up at 6 and the other one down at -3, right? So please, if they're parallel, then that means that they have the same slope. Now, and you're right, Daniel, they can be perpendicular. That's a mouthful. Perpendicular, the slopes are opposite reciprocals. Now listen to what I said, opposite reciprocals. So if I give you an equation, y is equal to 3/2 x plus 9, and I give you equation y is -2/3 x plus 12. The slope of this one is 3/2. The slope of this one is -2/3. That says that they're going to be perpendicular. Fair enough?
Mm-hmm.
Okay. Make sure I hadn't left off anything. One last concept we need to look at. And it goes like this. Okay. 2x plus 3y is 12, and I want us to find the slope. Well, there are 2 ways of doing it. I'm going to do it the easy way first. And the easy way first says that I'm going to write the equation in the slope form. So I take my original equation, and I got 3y is -2x plus 12. Now, all I did is take that 2x and move it over to the other side. Now I'm going to divide everything by 3. Plus 4. So now I can look at it. How much is my slope?
-2/3.
Right, the slope is -2/3. Agreed? Okay, to me, that's the easy way to do it. The other way to do it is like this, but you can handle that because you know how to find the intercepts. So if I let x be 0, if I let x be 0 in this equation right here, doesn't my y come out to be 4?
Right.
Right. Now, if I turn around and I let y be 0, doesn't my x come out to be 6?
Right.
Right. Now, I can use my formula. And my formula says you subtract the y's, so I got 0 minus 4. You subtract the x's, you get 6 minus 0, you get -4 divided by 6. But when you reduce -4 over 6 down, you get -2/3. Fair enough?
Right.
Now, my first reaction is this. Which is the easiest for you? Can't make a choice on it, no? If you can't make a choice on it, then I recommend that you take the top method, that you put it in the form y is equal to mx plus b. Now, Kevin, I have another reason for that. And the other reason for that is this. When you put these things into your calculator to draw a graph, that's the form that they have to be in, Alicia, to draw it. Your calculator won't draw it in any other form. You have to put it in the form y is equal to something other for it to draw the graph. Okay, we've done well. It's taken us almost 45 minutes to get this done. And that's the reason my other class I moved to 2:15 so I can have time to download this. And I'll post it again. And just like Daniel, so is this time going to work out all right for you on Tuesday and Thursday?
Oh yeah, that works great.
Kevin, you said you could be here, right?
I can make it to any time. I can work
All right.
around it. It's fine.
Alicia, what about this time for you?
The other time was better for me, but doesn't really matter.
Okay, I'm gonna go ahead and leave it at this time, at least for a couple of weeks, and we're gonna see how it goes. Y'all have a good day.
Thank you,
Thank you.
Professor.
So,